Eric Walenza, founder of IoT One, and this is the Industrial IoT Spotlight. Every episode, I interview one expert about a project that is impacting businesses today. Visit us at iot1.com to learn more, or email me to start a discussion. Welcome back to the second part of our discussion with Carsten Metelmann, VP of International Sales for EPLAN. In this second part of our discussion, we're going to be focusing on EPLAN's technology and specifically on how the technology is evolving based on a couple trends, globalization, cloud, and the IoT. I know that you've launched recently a new SaaS-based solution, Cogineer. And, when you're describing these two forces, globalization and cloud, I think Cogineer, you could say, kind of addresses both of these, or maybe it was motivated. You can give me some more, input into the motivation behind this new solution. But my limited understanding of the solution is that it's a SaaS-based solution that's intended to be somewhat less complex or more automated. Give us a bit of an overview of how the architecture and the functionality of this new solution compares to your traditional installed software.
Well, you just mentioned on a new product, it's called Cogineer, CO, and then Geneer part of the engineer. It's called Cogineer, part of our EPLAN product suite. It's fully integrated into the suite, but it's also something completely new. What have we done? You have to understand that EPLAN is a very traditional software sold as a license that runs under Windows, develop the .NET environment and so on. And we've done this in that environment for about 30 years. Of course, we've always changed. We've always evolved. We have a major release every year, and we have this service pack or minor release every between major releases. What we thought was, coming to demographic change, the software evolves, takes on more and more features, and as you increase features, you also increase complexity. And we believe that in the current workplace environment, it's desirable to reduce complexity, but still to come up with high quality, highly integrated, high-level design and engineering data that makes engineering just much smoother. If you look at that situation, it's really like an optimization question. How do you do that? How do you achieve both? Create a software that is easy to use on one hand. On the other hand, achieves highly sophisticated design. And what we did was we added a little add-on. It's just a little add-on to our most popular software, which is called P8. It's a software for electrical engineering, making schematics and so on. And this is a completely Windows-based, and you have all these windows and just the graphical user face you're used to from Windows. And we added a little, like a cutout, a little window in the center. And the window is actually a configurator. And the purpose of the configurator, we call Cogineer, is to enable users to come up with electrical design without having to touch the electrical engineering software itself, without having these drawings, to draw the drawing or to engineer, pick and place one component here and one component there. We wanted to create a simple, intuitive way that customers can actually operate the software and generate high-level, good quality design through just a pick and place menu. Just a multiple choice menu, more or less. And in order to achieve that, we have done something new. As I said earlier, we have one software for the whole world, more or less. So that software, if you hand that software to a team of engineers, like 10 engineers, electrical engineering team of 10 engineers, they all operate the software, they're all on the same level. Okay? So they work together seamlessly, fine. Everything's fine. But what happens when you have a team of 10 engineers, of which 5 engineers are like 55 years old and close to retiring? Okay, you replace them. Maybe you replace them with 3 new engineers because you cannot find more than 3 in the market. Now, the new engineers are not as experienced, and maybe they're not on the level yet as the older experienced engineers that are retired. So now you have a team of 8 engineers, whereas you may have 2 or 3 very experienced, but you also have a bunch of people who are not so experienced. So we wanted to create a tool that produces a high quality design and can be trained in less than half a day, or maximum half a day, 3 to 4 hours. In order to do this, we split up the roles. We call it roles. We have created 2 roles in Cogineer. One role is for the experienced engineer. The experienced engineer is called a designer. Under Cogineer, the designer can define the rules for the others, less experienced or less privileged engineers to follow. And these are the other less privileged engineers. They're called the builders. So what we've done, instead of having 10 or 8 people all working on the same software, we now have 8 people who still work on the same software, but in 2 different roles. So you have, in a team of 8, you would typically have 1 or 2 experienced people who set the rules, configure the configurator. We have certain ways of doing that and supporting them. Maybe I shouldn't go into too many details. But the purpose is to make life easier for the 3 or 4 or 5 less experienced engineers. And this package suits, it's very suitable for the way large multinationals and small, medium-sized companies actually work. When you have a team of several engineers, you usually will have 1 senior engineer and a few junior engineers. And Cogineer is tailor-made to fit that environment. And to sum it up, of course, we have a business purpose with Cogineer. The business purpose for Cogineer is by making it so easy to adapt. We want to attract new users. And we call this Cogineer, we call it a tool for the mass market, meaning all electrical engineers in all manufacturing companies. So that's Cogineer. I don't know whether this was too much technical or whether I made my point clear.
I think your point's very well taken. I was talking with a couple other companies that had very similar focus areas. One is a Silicon Valley-based startup called Vantic. They're doing an IoT application development platform. And the core value proposition is that you can come on board the platform from a traditional company with a very limited IT team, and you can build sophisticated IoT applications that pull data in real time, and they basically operate in an event-based environment that, using traditional methods, you would have to have a very sophisticated large team that has expertise in 10 or more software languages. Another company you probably know well is Werma, a German company that produces hardware and to an extent software for production lines. Their focus also very much on how to design tools that allow you to manage a complex and increasingly complex environment, but that focus on simplicity. And I think in the IoT space, this is incredibly important, is that as we increase digitalization, we are adding layers of complexity on top of systems in terms of we're adding electronics, for example, to a lot of equipment that was previously primarily mechanical. Or we're adding an IT layer onto systems that used to be maybe a mix of mechanical and electronic. And this complexity, if we want our customers to be able to accept this complexity, we need to package it in solutions that are simple. So it sounds like Cogineer is doing this. If we compare, maybe give me another benchmark. You said it takes 4 hours or so to get somebody to a builder layer. I'm assuming that this is somebody that has a solid engineering background. With the traditional EPLAN, I've seen EPLAN on people's CVs, so I know that it's a serious piece of software that that takes some time to learn. What would the learning curve typically be for gaining competence in the traditional EPLAN software, the P8?
Well, we offer trainings everywhere, and a training course starts from 5 days. Right, that would be a basic training course, but then you're just a basic user of the software. And as I said, what we actually do is we go beyond electrical engineering. We promote automation, and as you and we do this through standardization. And to understand how this is done, you really have to be familiar with the software. And here I would say it takes, even for very bright people, it takes at least half a year of practice, and usually takes more than several years for you not only to be familiar with the software, but to explore the software can be utilized to simplify your workflow. It's not only about drawing, it's also about workflow, the work where you work. So I'd say that it's a good point that you make. Ease of use will become a much more important issue, decision-making issue in software purchasing and IT purchasing in the future. And we don't only want to react to that, we also want to shape that development.
So another trend that you pushed on was the adoption of cloud. Cogineer, is this a public cloud-based, or is this are your customers typically using this on a private cloud? How does that implementation differ?
Well, they can be used on a private cloud. It's all our new software, all the new software that we're publishing, all the new versions are available in the cloud or can be downloaded, and we also shift to a subscription model. We run both models. As I said earlier, we were kind of conservative, and we're very successful with the traditional license model, where companies purchase licenses, use CapEx, purchase some licenses, and we now also offer an OpEx-based model because this is a trend. It's a trend that everybody's moving to cloud. Everybody includes our customers, and they are much more comfortable now to purchasing services and software and hardware through the cloud and purchase it and pay with operational expenditure.
Mm. And then you described earlier that the various stakeholders that are involved here. So maybe the engineering is driving the adoption decision, but then we have maintenance, we have supply chain. How is the data managed here? Do we have interaction between data silos and between functions, between in-house and suppliers? How do you see this evolving? Because obviously data management, especially when the cloud is involved, is it's a pretty key issue for companies, or it's an issue that I would say a lot of companies are just not that familiar with, and for that reason, it's a discussion point. How do you manage data across the different stakeholders on the platform?
Yeah, that's a very, very important and also a very big question. There are at least two aspects we should look at here. EPLAN, of course, also based on a database. The database is usually kept within the company. It's not on a public cloud. It's a maximum on a private cloud. And, EPLAN is not a software that works in isolation. We link up with ERP systems. We link up with PDM system. PDM is product data management. We link up with mechanical tools, mechanical engineering tools. So we are part, from customer's point of view, we are part of an IT infrastructure. And depending on the way the customer sets up this IT infrastructure, the database is either mainly kept in a PDM environment, product data management environment, or within a PLM environment, product lifecycle management. And we adapt to that. So we plug into this. And we contribute to this. And we exchange data with that. Integration is key. It's absolutely key, a key topic for us. But we're not alone, so to speak. Mm. We're here, we talk with the CIO, we talk with the various departments. And because we're a niche provider, usually in the purchasing cycle, companies will first go and purchase an ERP system. And then they will go and purchase mechanical engineering and PLM and PDM tools. And only after that, they will turn to EPLAN and talk with us about electrical engineering, automation, and how to manage all the data. So the funny thing is that we are just a small player compared with Autodesk or SAP or Oracle, but a lot of these integration questions actually come to us. All right? So, and we have developed what we call connectors. That's standardized interfaces towards the most popular tools in the software, and also towards interface tools for interaction with PLC, programmable logic controllers, PLC manufacturers. All the big PLC manufacturers in this world, like Siemens, ABB, Schneider, Mitsubishi Electric and Rockwell Automation, they're also partners of EPLAN. Because by facilitating exchange of data between the various players, you just dramatically increase the efficiency and safety of the whole system. It's a huge point. So that's one thing. The second thing is that we do operate a cloud portal. We call it the data portal. And on the data portal, you can find all kinds of components, mainly low voltage components that are used in electrical engineering. The idea is that we want to facilitate that the users create their own product database. We facilitate that by offering high quality, what we call macros, high quality data sets through the internet. That's hosted in the cloud and is a portal where by now I think we have almost 200 manufacturers on there. We have more than 500,000 parts. And it's not only the drawings, all these data sets, they come with all kinds of electrical parameters and logic. So that's one way. And the way we manage data here is actually on the data portal. On this, we are just a host. We are hosting the product data, and the product data in itself are always provided by the component manufacturers because they own the product, they know it best, and which is very, very important, they can update fastest when they have new products. So we don't own this product data. We own the platform, we host the data, and we do quality assurance. That's the second issue. And I mentioned two views, but there's another view as the third view. And this is something that we started doing a couple of years ago. I think it was 2 years ago that we started also looking at new protocols. New protocols, how we could address instruments remotely from our system. As you know, electrical design used to be static. Used to be like in this value chain between engineering, purchasing, manufacturing, and so on. You have a design, then it's frozen. It moves from engineering to manufacturing. Maybe it's changed, but then it's frozen again. And then it's handed over in any kind of format to the end user. But with the new technologies, be it Internet of Things, be it that there are devices that are Internet enabled, you can use different ways of dealing with data and addressing instruments or machines through remotely by manipulating the data. So, for instance, we on the basis of an open protocol, it's called OPC UA. I think many OPC UA, quite a popular protocol in various areas. We have created a kind of tailor-made version of our software where we address from the electrical engineering, we can calibrate, supervise, monitor field devices in the field, in plants, in remote installations. And this goes through, we just use this OPC UA protocol. So this is a new thing. And we are doing this because new technology makes it possible, and it's some of our customers interested in this, and especially component manufacturers also interested in this and providing some added value that goes with the components. If components can be calibrated, commissioned, and monitored remotely, that's an added value from a component provider point of view. So they are interested in looking into this direction, and they come to us and they develop solutions together with us.
Great point on the ecosystem importance here, right? This is certainly not something that you want to be challenging yourself, and there's neither possible nor desirable. And so very, very important to place yourself in the right position in the ecosystem. And it sounds like ePlan's done that. I've talked to a good number of companies that are, I would say, a little bit less certain around their place in the ecosystem, especially hardware companies that are finding themselves in environments where solutions are adopting more software, and they're trying to figure out how to reposition themselves to still have a profitable, relevant place. But it sounds like ePlan not such an issue. You guys you're basically providing a solution for a growing market. Thank you for joining the second part of our discussion with Carsten and ePlan. You can learn more about EPLAN at www.eplanusa.com. Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. We help to accelerate digital transformation by advising business leaders on how to integrate IoT technologies into their operations and products. We appreciate your thoughts, suggestions, and of course your reviews. And if you have an interesting project, we'd love to feature you on a future edition. You can write me at eric.walenza@iot1.com.